Hi everyone, welcome back to our channel. So today we are going to write down the KVL equations for the given coupled coil. Let us assume that this is a transformer primary and this is a transformer secondary. So this is a transformer equivalent circuit indicating the primary winding as well as secondary winding. The self-inductance of this coil is given as plus J omega L1, which is nothing but we can write down this also S plus J X L1 ohms. It's nothing but inductive reactance. And here also the self inductance of the second coil is given as plus J L2 ohms. Okay, so this is given as plus J omega L2 ohms. But these two inductors are coupled with an mutual inductance of plus J omega M12 ohms. The ultimate units of here is also ohms. Okay, so this is what the data given to us. Let's try to write down with respect to KVL equation. So we need to write down the KVL equation. In order to apply the KVL equation, let's try to apply mesh analysis. So this mesh analysis or loop analysis, both are same. Apply mesh analysis or loop analysis for the first loop. Okay, so this is nothing but indirectly we are going to apply the Kirchhoff's voltage law. Let's try to write down the equations in the form V is equal to I into R. Okay, you can see here. So here the current is flowing. It is already mentioned in the problem. Current is entering the dot, and here also current is leaving the dot. Whenever one current is entering the dot and another current is leaving the dot, therefore you are going to get the mutual inductance as negative. Let's try to do it for the first loop. Let's try to write down here. So here you are going to get V1 is equal to, where V1 is the voltage source. Voltage source is equal to voltage drop. So what is the drop created by this inductor? I am going to write on it as I into R. Okay. So what is the I value? I1 into R value is how much? Plus J omega L1 ohms. Okay. So this is nothing but for the first coil. But first coil is linked with the second coil with the mutual inductance of plus J omega M12. But what kind of polarity how to mark is? So this is current I1 is entering the dot. This current I2 is leaving the dot. One current is entering the dot, another current is leaving the dot. Therefore, you are going to get a negative polarity minus of I into R. So here we are writing for the first coil. Mutual inductance is due to another coil current. What is that another coil current? Which is nothing but I2 into R. What is the R value? It's nothing but the mutual inductance plus J omega M1 2 ohms. This is in the form of I into R. This is nothing but I into R. You can see here, this I can call it as self-inductance and this I can call it as mutual inductance. Mutual is due to another person. So the mutual inductance due to which current? I2 current in another coil. Okay, I1 is the self current where we call it as self-inductance. This is how to write down the mesh equations or the loop equations for the coil 1. Let's try to write down the mesh equations or loop equations for second loop. Okay, so here you can see here what is the voltage source we are applying is V2. Okay, so V2 is the voltage source, and you can see here it has a self inductance of I into R. What is the I value of the one coil is I2 into R. R value is plus J omega L2 ohms. I into R. But this second coil is linked with first coil with the mutual inductance of plus J omega M12. But what kind of polarity you have to mark is so you can see here the left hand side what I am writing are voltage sources. What I am writing on right hand side are voltage drop. Here also what I am writing in left hand side is a voltage source. What I am writing in right hand sides are voltage drop. The first term I am writing is the self inductance. Okay, that's how we should have a clarity of writing the equations. Okay, now you can see here second coil is linked with first coil with a mutual inductance of M12. Okay, how to write down is here current is leaving the dot. Here current is entering the dot. Therefore, the mutual inductance you will get it as a negative polarity, and you have to write down the drop as I into R. So here the mutual inductance in the second coil is due to first coil current. Already I told mutual means due to another person. Okay, so here the mutual inductance is due to current flowing in the first coil. Okay, I1 is nothing but I into R. R value is how much? Plus J omega M12 ohms. So this is the form I into R. Okay, so now we can see here this equation is having I1 terms as well as I2 terms. This equation is also having I1 terms and I2 terms. This is the style of writing the equations. Okay. So if you want to write down in S domain, just substitute S is equal to j omega. The same equation is asked in S domain. We can just simplify this equation and we can write down it as V1 of S is equal to I1 into this S is equal to j omega. You can write down it as S into L1 minus I2 into this can be written as S is equal to j omega S into M1 2. So this for the second equation we can write it as V2 of S is equal to I2 into I can write down S is equal to j omega into L2 minus I1 S I can write it as S is equal to j omega S into M12. So this is how to write down the equation if S domain is asked. So many of the examiners ask us write down the given values in S domain. This is how to write down the input KVL equation. This is how to write down the output equation. So if you feel my content is useful to you, please give a like to the video and share to your friends, those who are studying this same subject. If you have any doubts, let me know in the comment section. And if you are watching my channel for the first time, subscribe to my channel with the name kvthulasi. Okay, so kindly support this sort of free channels for the development of students and faculty. Thank you for watching my content patiently. We will meet in another video. Yours, Ram.